Well, this is my first time at this conference. I understand it's been going on for a number of years now. It's my privilege to be here with you this morning. My name is Psarris, and I'll be your creation speaker this time. For the next 2 days, I have 4 talks scheduled, which is a real privilege. As you can see, this talk is called Biology Confirms Biblical Creation, but before I get on the subject, maybe I should address a larger issue. There's kind of an awkward question that I know many people have, so we should probably talk about that first. And that is, who allowed a guy like me to come to a conference like this? I mean, there's been some kind of lapse in judgment, right? Everybody's here to talk about the end of times, and I show up and I only want to talk about the beginning of time. I mean, what's going on with that? Well, evolution and creation is an important issue. A lot of people aren't necessarily interested in what the Bible has to say about the end times. And a lot of the motivation for that is that they've been told that we didn't come from a creator. We came into being from this long process of Darwinian evolution over millions of years. No creator was involved. So who cares what the Bible says about the end times or any other topic? And this is an increasingly severe problem in our culture. Now, I'm from the South, down in the States, and I'm assuming Canada has the same secularization issue going on that the U.S. does. We are a post-Christian culture. It used to be people understood that the Bible was accurate and talked about history and so on, and now that's not necessarily true. Biology specifically is an area where we are told that there's all this evidence that there was no creator involved in our origins, that we got here from different means. So that is my first subject here at the conference is, what does biology have to say about where we came from? As you can see from my title, I'm asserting that biology confirms not Darwinian evolution, but biblical creation. So let's talk about all those 4 words. What is biology? Well, biology is just the study of life. Bio means life, and ology means study of, so therefore the biology is a study of living things. What do I mean by confirms? Well, I'm not saying biology proves biblical creation, and that's why we should believe the Bible. The Bible is God's word. It stands on its own authority. We don't believe it because we think we have scientific evidence for it. Now, there is scientific evidence consistent with it. So that's my position on this. We're not trying to prove the truth of Scripture. Scripture is true, period, whether or not our current scientific opinion happens to conform to it. But in this case, as in the other sciences, there is indeed scientific evidence consistent with it and against the secular view of things. So what do I mean by biblical creation? Well, hopefully that's fairly straightforward. The idea that we got here as a result of divine creation as described in the Bible. Now, of course, this is not a popular view in our culture, is it? We are told instead that Charles Darwin is the proper foundation for an origins worldview, that Darwin, in his book on the origin of species by means of natural selection, really laid the groundwork for a correct understanding of how life and all the various living creatures came to be. And indeed, this is the majority opinion within our culture today. Lots of books like this one here, Why Evolution is True, by a particular popular evolutionary biologist. And this is an important issue for us because this isn't merely some obscure scientific question. Whether or not we got here from a divine creator or from natural processes has very important implications. Darwinism has been called the universal acid that eats through worldviews. You may be familiar with the phrase universal acid means, what if you had an acid that was so effective it could eat through anything? What kind of container could you keep it in? And obviously you couldn't, right, if it's going to eat through anything. Well, Darwinism has been called the universal acid in the question of origins because it actually destroys the need for any sort of theistic explanations, any sort of explanation relying on God being involved. Darwinism claims to explain life's origin, its diversity, and the appearance of design. As Stephen Hawking once said, and he was an atheist, by the way, if you didn't know that the overall Darwinian worldview leaves nothing for a creator to do. And indeed, in Western culture, before Darwin, not that everybody were Christians, but at least people had a Christian worldview, and there were a lot of arguments among philosophers for the existence of God because of things like design, because of the fact that life exists, because there's this world around us. Well, Darwinism answers all those questions, or at least so this is claimed. In fact, atheist Richard Dawkins has said that evolution is such a big idea, it's amazing really what Darwinian processes can do. He says Darwinian natural selection can produce an uncanny illusion of design. An engineer would be hard put to decide whether a bird or a plane was the more aerodynamically elegant. He went on to say, so powerful is the illusion of design that it took humanity until the mid-19th century to realize that it is an illusion. And then he goes on to explain how Charles Darwin's ideas was really the groundwork for all of this. Now, despite the claims of secular scientists and atheists like Professor Dawkins, the Bible is true. All claims to the contrary are either incomplete, incorrect, or, quite often, both. So we're going to contrast the two worldviews here in my session this morning. We're going to look at the Darwinian worldview and see, does this actually match what we see? An overview of my talk here this morning, I'm going to spend a lot of time debunking neo-Darwinian evolution. We're going to talk about the mechanism for it. We're going to talk about claims that it actually happened in the past. There's claims that there's evidence for that. We're going to talk about claims that it's happening right in front of us today in the laboratory. Then we'll move on a bit and we'll talk about evidence for design in biology. And of course, if there's design, then there had to have been a designer, right? And the last thing I'll talk about is evidence that the Bible specifically is the accurate account of who that designer is. And that, of course, would be God. Now, you may be wondering, first of all, if you're not familiar with this subject necessarily, what do we mean by neo-Darwinian? What is neo-Darwinism? Well, neo, that prefix just means new, right? So neo-Darwinism is the current consensus view among secular biologists for the issue of where everything came from. In Darwin's day, genetics was not yet understood. So Darwinism, as he first proposed it, is not really believed in that form today because his ideas on genetics were wrong. And that's not really his fault. Nobody in his day knew that yet. So Darwin's views, when combined with modern ideas of genetics, is called neo-Darwinism. So when I talk about Darwinism or neo-Darwinism in my session here this morning, I'm talking about the same thing. So in case I forget to say neo, just for clarity there, that is what I'm saying. So neo-Darwinism is kind of an awkward phrase. We're more often just talk about evolution. But what is evolution anyway? If we're going to talk about that as a subject, we need to get some definitions here, don't we? Well, here's a Wikipedia page for evolution. And there's several things that I want to focus on in the actual definition as given here. Now, of course, Wikipedia is not an authority, but it's usually a decent reflection of where the culture is. So what Wikipedia said, evolution is change in the heritable characteristics, in other words, the characteristics that can be inherited and passed along from generation to generation, the heritable characteristics of biological populations over successive generations. So the key part of this first sentence is this first part, evolution is change. Any change that can get passed down to offspring is evolution, according to that first sentence. The second sentence says, evolutionary processes give rise to biodiversity. Well, that part doesn't actually say much. It just means the process of change produces change. Well, that's not very helpful. Then it goes on to say at every level of biological organization. Now the third sentence, all life on Earth shares a common ancestor, known as the last universal common ancestor. So this gets into an idea called the tree of life. And if you probably studied this in school or seen this on a science program or whatever, the idea that there was way back millions of years ago, this origin of life, the first living thing that then evolved over successive generations. And of course, man is at the top of that tree, right? We are the pinnacle of evolution as we understand it. Now, our most recent compadres in this process were ape-like creatures. Notice that we didn't come, supposedly, directly from chimps, but we do have a recent common ancestor with them. So people sometimes say we didn't come from monkeys. Well, that's true. Even the evolutionists don't believe we came from monkeys. They believe we came from monkey-like creatures, which is basically the same thing as saying we came from monkeys. But just to make that specific point. And then all living creatures supposedly came from the very beginning from the very first living creatures. So this is all built into the idea of evolution in our culture. But think about this, though. We get a couple sentences here that are really talking about very different things and all lumping it together in the same term here, aren't we? There's a logical fallacy called equivocation, where you start talking about something and then you switch the definition of one of your words in the middle of your argument, and you keep going as if it's the same thing. That's really going on here in this discussion. The word evolution is a rather vague term that's used a lot of different ways. And frequently in the creation-evolution discussion, you will hear evolutionists say, well, look, we have evidence for evolution here, and they're talking about one definition of it, and then that proves that evolution is true here. And here they're using evolution in a very different way. Specifically, they'll often say, well, evolution is change. So they think that if they demonstrate any kind of change in a biological population, that proves evolution is true. But then they flip the definition of it and they say, well, therefore we know that molecules turned into men over millions of years. Well, that's a totally different thing, isn't it? There's another logical fallacy going on here called unwarranted extrapolation, where you're taking a pattern and then extrapolating it far beyond the area where it's applicable. For example, I mentioned I just had a birthday recently, and I'm not getting any younger, it turns out. But, I can still, over short distances, I can run about 10 miles an hour. So I did some calculations. I said, there's some things in life I still want to do that I haven't done yet. I can run about 10 miles an hour, so if I started running tonight, I calculated, I can reach the moon by my 80th birthday. And I've always wanted to visit the moon, so that would be really cool. Now, there's obviously a problem here, right? First of all, I can't run this for any appreciable length of time. And second of all, it doesn't matter how fast I could run, I'm not going to make it to the moon. Well, the same thing, because there's this unbridgeable gap between me and the moon, isn't there, that running isn't going to help me with. And the same thing's going on here. Evolutionists frequently think, or claim at least, that because they can show that in the world today we see some small changes and we see natural selection going on, therefore molecules turned into people. Two totally different subjects. In fact, a lot of the things that they argue for here, I don't have a problem with. Are small changes possible within a biological population? Yes, and the Bible actually implies that it's possible anyways. This isn't a problem with the Bible. Genesis 1, God blessed them in saying, be fruitful and multiply and fill the waters, the seas, and let fowl multiply on the earth, and so on. The Lord created life to fill the earth. So it would make sense that he would create life with the ability to move into an ecological niche and adapt to it, to be better suited to it. So the Bible is consistent with small amounts of change, not because of neo-Darwinian processes, but because the Lord designed life with a programmed ability to adapt to things on a small enough scale. Natural selection is not a problem either. We'll be talking about this here in a little more detail later. Darwin didn't actually invent the idea of natural selection. It's fairly straightforward reasoning that such things would happen. And indeed, the Bible even is not inconsistent with the idea of new species forming. In Genesis 1, it's said 10 times that vegetation, birds, and etc. were created each according to its kind. A biblical kind is not the same as a biological species. Species is a recent idea that was invented to try to sort some things out within biology and make things easier to categorize, but it's not the same level as a kind. Now, the Bible talks about there being kinds of creatures, so new kinds are not possible because that's what the Lord created, but minor variations, perhaps to where you could have a new species, well, I'm arguing that the Bible doesn't have a problem with that. And I should clarify, too, what does it mean for a species? Even if you ask a biologist what a species is, by the way, you'll get different definitions. It's a really fuzzy concept. But a good working definition is if two animals cannot interbreed and produce viable offspring. So you can imagine then that a population could have enough change within it so that you eventually get some creatures that can no longer have viable babies together. And those are new species, quote unquote. But they're not new kinds. So if you have a cat kind, then you can wind up with lions, tigers, jaguars, cheetahs, which will be different species. But you can breed those animals as long as you want. You're never going to get a version of a dog, because that's a different kind, right? So Darwinists will frequently point to evidence for new species and claim that that disproves the Bible. That's not true at all. The Bible talks about kinds. There's a hard limit to biological change, but it's at the kind level, not the species level. So therefore, a lot of examples of change that are presented to us as proof of evolution actually are not, are not inconsistent with Scripture, but this whole tree of life business is completely unjustified, both scientifically and biblically. So because we know the Bible is true, what should we expect to see in biology then? Well, we should expect to see evidence of a supernatural designer. The Lord is an amazing designer, far better than any human engineer, beyond our ability to understand, really. We should see some amazing evidence of that design within biology. We should see a lot of leftover beauty from his initial creation. Now, granted, since Adam and Eve fell and brought sin into the world and death, life is currently under bondage to corruption. There's death in the world. There's evil in the world. There's pain and suffering. That's because of sin. So we would expect biology then to show us a mixture of beauty from God's initial creation, having been corrupted, though, by the effects of sin. We would expect to see a programmed ability to adapt to environments, like I talked about before. If the Lord created life with the intent of having it go fill the earth, all these different ecological niches, then presumably he would have given it the ability to do that. That adaptation into new niches could perhaps lead to new species. Adaptation to the point where this group of animals can no longer breed with that group of animals, but they're still within the same kind. And all kinds are in place at the beginning of creation. And as I said, a hard limit to biological change. No new kinds are possible. And then mass extinctions after a global flood, Genesis 6 and 7. Now, we're going to see this in biology. We're not going to see what the neo-Darwinians expect, however. So back to our overview. Let's spend some time now talking about neo-Darwinian processes and the mechanism specifically. We'll talk about the claims that evolutionists make for what we see in the world around us, and then we'll look at whether or not those claims can be supported by what we actually see. So at the very beginning, it's a good place to start our discussion, right? The evolutionists claim life started by itself, that there were these non-living chemicals, and then they got together, and suddenly they were a living creature for the very first time. Now, it used to be said that this happened in some warm pond somewhere millions of years ago. Lately, some people are shifting more toward a hydrothermal vent origin model. And if you ask an evolutionist, well, what evidence do we have that such a thing is even possible? You will frequently be pointed to the Miller-Urey experiment back in 1952, where this contraption in the laboratory actually produced over 20 amino acids. So this is worth spending a few moments on. So Miller took some water, representing the early ocean, and it had a heat source here to keep it warm. And so that turned into water vapor. Well, the water vapor would circulate, and then he zapped it with electrical sparks to represent lightning. And over here, by the way, he had some gases that represented the early atmosphere. So he found out that when there's his early atmosphere being zapped with lightning, quote unquote, with water vapor in it, that when he condensed things out, he found some amino acids were formed by this whole process. The combination of the water vapor with the chemicals in the atmosphere, and so on. And so amino acids are the building blocks of proteins, and proteins are the building blocks of life. So Miller created the building blocks of life right there in the laboratory. So that's the claim, that life started by itself. We have evidence for it, and indeed we've seen in the laboratory how such a thing is possible. Reality, though, is very, very different than what the evolutionists claim. We could actually have a whole session here just on the problem of how life could have formed by itself. There's numerous reasons why such a thing would be impossible. For example, DNA in our bodies, and for that matter other living creatures, contains the instructions to build proteins, and proteins are like the molecular machines within the cell. But the thing, DNA needs proteins in order to make copies of itself and for the cell to divide and so on. So you need DNA to make proteins, but you need the proteins to make the DNA. So which of those came first, if you're going to say something did come first? To make sugars without enzymes, you need an alkaline environment, but to make amino acids, you need the opposite, but you need both in the cell. How are you going to do that if you're just mixing chemicals together? To make nucleotides, you need formaldehyde and cyanide. Those are some pretty nasty chemicals, which would destroy proteins. Again, we're seeing some chicken and egg problems here. And there's a lot of other requirements, too, to have life. Life has very sophisticated error correction built into the DNA processing. You need information storage and retrieval systems. You need factories for making proteins. On and on it goes. And a lot of this gets rather technical, and it's outside of my topic here this morning, but this alone discredits any non-creation origin of life. In fact, this problem has gotten so severe as Dr. Paul Nelson gave a whole lecture on this subject, biochemists are starting to abandon the idea that we all share a last common ancestor, that everything came from this tree of life with one thing in the beginning. There's some things being discovered at the very lowest levels of chemistry within the cell that makes this impossible. He has a whole YouTube video on it. If anybody wants to watch that, you can come see me afterward. I'll give you that link. What about this experiment, though, that showed you can make amino acids in the laboratory? Well, it doesn't really show what they claim that it shows. First of all, it does create amino acids, that's true, but it turns out every time you zap the mixture with lightning, while you're creating new ones, you're also destroying the old ones. That's why Miller had to put this trap in his system to filter out the amino acids to preserve them from being destroyed as they went around this loop. Also, something was confirmed here that's well understood from chemistry. If you make amino acids at random, well, there's two possible configurations for amino acids. This is called chirality. There's the left-handed version and there's the right-handed version. And if you make amino acids by mixing chemicals together, you get 50-50 of each kind. The problem is life is made exclusively of this kind. So if you're going to make amino acids at random, you get a mixture of both. If you have a long chain of amino acids and there's even one of these, then life is impossible. You need exclusively only those. So the chemists have been beating themselves up for 50 years now trying to figure out how can we come up with a process that only makes these, and you can't do that. Moreover, it turns out that even if you do have a solution that only has these kind, let it sit for a while and half of them will revert over to this until it's an even mixture again. So there's important chemical reasons why having a bunch of amino acids doesn't really help you get anywhere with life. Moreover, this experiment, even among evolutionists, is considered to be obsolete today because what Miller used as the early atmosphere, quote unquote, is no longer believed to represent what the early Earth had in their model. And this whole thing says very little anyway. I mean, just because you mix some amino acids in the laboratory does not get you very far in explaining all of life's complexity. That's like saying that, you know what, I figured out a way that if I mixed together some chemicals to make some ink, and that explains how encyclopedias evolved by themselves from nothing. Does that really help you? No. Obviously, there's a lot more in an encyclopedia than just the ink. Not to mention all the information that's coded within that ink, right? That's a non-material thing, cannot arise from natural processes. Okay, moving onward. We've seen the origin of life thing from evolutionists' perspective does not work. Another claim is that the process of evolution is driven by mutations plus natural selection plus time, and that this can explain all the amazing complexity and diversity that we see around us. So this will take me a moment to explain what's going on here. The engine for Darwinian evolution is really this, mutations. So within our cells, there's DNA. You've probably heard of this. DNA is this amazing molecule that can contain a lot of information in a very small space. And DNA is actually how the cell stores its blueprints for doing everything it needs to do. It's got all the instructions for making proteins, for example. So the cell actually reads its own DNA and uses the instructions encoded within to do all the various things it needs to do. Well, when cells multiply and new cells are formed, DNA has to be copied for the new cell, of course. Sometimes that copying process doesn't work exactly correctly. Sometimes changes are introduced to the DNA molecule meanwhile. Or changes can come in some other ways, like from radiation or some other external environmental event. We call these changes mutations. So when the genetic information gets changed somehow, that's a mutation. So you can wind up with a baby that's a little bit different than the parents in some ways because its genetic material has been changed in some way. So mutations, therefore, introduce changes into biological population. That's step one in the Darwinian process. Step two is natural selection, which chooses from among all these changes and preserves some into the future. So the idea is that if you have a population, so all these older animals are having younger ones, the younger ones have a variety of mutations. Natural selection will throw away the bad mutations, and those ones don't reproduce anymore the organisms that had that. And then the organisms with the good mutations, natural selection will preserve. So that when that generation has babies, now we're getting a higher percentage of this good mutation that's been preserved by natural selection. So let me talk about this a bit more. Among mutations, of course, you can have good ones and bad ones. Now, bad ones are often either fatal or overtly harmful. And the ones that are bad, you can imagine that, in some cases the organism will die early, so it's not going to have any offspring, so natural selection eliminated that mutation. Or perhaps that mutation makes it more difficult for that animal to have offspring, so again, its chances are lower, natural selection will eliminate it. So the bad mutations that are either fatal or overtly harmful, natural selection will remove from the population. On the other hand, though, some mutations could be beneficial. There's an example within humans. Specific genetic characteristics cause red hair. Now, most people in the world do not have red hair, only a few do. We know genetically why the people who have red hair have it. Now, let's say hypothetically that having red hair made you more attractive and more likely, therefore, to marry and have children. I see some of the red-haired people smile and saying, yeah, preach it, brother. Now, from an evolutionary perspective, if you're more likely to marry and have children, then on average, the next generation will have a higher percentage of, in this example, red-haired people, right? So you can think over generation after generation how the percentage of people having that characteristic would grow. And in evolutionist thinking, whoever has the most babies wins. For a mutation to win, generation after generation, it will have to increase the percentage of organisms within the population that has it. So that's the basic idea behind natural selection. Let's say we start up here. Well, this one has some offspring with different characteristics. That's caused by mutations. Natural selection gets rid of the bad mutations and preserves these. Well, then these have other mutations with a different variety. Natural selection gets rid of some, preserves these. And so you see how over time you start with something that looks like this and you wind up with a population with different characteristics, right? So if mutations introduces change into the population, and natural selection can then guide the change by removing some and preserving others, you can see how change will propagate throughout a population over time, right? And evolutionists think that this can account for basically all the differences in life that we see. We all came from this single unicell creature millions of years ago that over time had offspring, some of which were a little different than the parents, and then they had offspring that were a little different than the parents. And do that over and over and over again, you wind up with this great variety of life that we see today. As this quote here says, time is in fact the hero of this plot. Given so much time, the impossible becomes possible, the possible probable, and the probable virtually certain. One has only to wait. Time itself performs the miracles. Is that a scientific statement, by the way? No. Nevertheless, this is really pushed in our culture. I mean, here's a children's book. Billions of years, amazing changes. Time is the hero of the plot. So that's the basic worldview that evolutionists are coming from. Mutations introduce changes. Natural selection throws away the bad and keeps the good one. And do that for a long enough time, and you can produce amazing things. Like Richard Dawkins said, it produces things that are so well adapted to the environment, it's an illusion of design. That's what they claim. The reality, though, is actually quite different. Natural selection is actually far less efficient than what evolutionists claim it is. Now, it's true that mutations that are fatal or very bad can be eliminated by natural selection. And that's just common sense, right? If something is really has obstacles to overcome in its way to reproducing, then of course it's less likely to do that. But most mutations are not that severe, and the ones that are can be eliminated immediately. But a lot of mutations are actually neutral to only slightly harmful. Natural selection is not precise enough to eliminate those from a population, it turns out. That means they will accumulate over time. Now, is it a bad thing for neutral or just slightly harmful mutations to accumulate? Yes, because even slight changes are generally actually harmful in different ways. I forget who said this. I think it was Dr. Dwayne Gish, but he said a lizard is a machine for making other lizards. It's very well designed to do that. If you start tinkering with the instructions a bit, well, it's not going to work so well on subsequent generations. Another analogy here is take a magnet and start waving it next to your computer hard drive. Do you think that's going to make your computer work better or worse? Worse, obviously. But natural selection, now, of course, if you wipe the hard drive, then you got to go fix things. Natural selection works in that case because you've destroyed your system. But what if you start tinkering with individual slight pieces of information in your hard drive? What if you modified a part in a word processor that only works with certain fonts, for example? You destroy the ability to use certain fonts. Well, most of the time, the computer will still work fine, and you won't notice because you only use those fonts once in a while. But you keep making those little changes over time, you don't notice, but suddenly you reach a point where things don't work that well anymore, right? Anyway, so slight changes, slightly harmful to neutral mutations, will actually accumulate in a population over time. Natural selection can't fix that. Moreover, even preserving good ones doesn't necessarily help. What do I mean by that? Well, I talked about mutations producing red hair, but as we also know, people with red hair tend to have very pale skin, more liable to skin cancer, right? So if you had an adaptation or a change that makes you more likely to have children in one respect, but more of a struggle to have a higher life expectancy on the other, well, now we got competing things here, right? Natural selection's not going to work as well as the simplistic view would have it be. And because of the way DNA works, when you change something on a DNA strand, you're often affecting multiple genes, which means a single mutation can have multiple effects within an organism. So add all this up, and what do you get? The simplistic Darwinian picture of natural selection keeps the good and throws away the bad, and so we're always getting better and better. Actually, the opposite is true. It can throw away the really bad stuff, but it can't affect the stuff that's only slightly bad or neutral. So over time, we're accumulating more and more mutations. Dr. John Sanford is a geneticist from Cornell University, and by the way, was a hardcore atheist most of his life, is now a creationist and a Christian. Wrote a book called Genetic Entropy that deals with this, and he says if you look at the mathematics of mutations within populations, we're accumulating a genetic load generation after generation. And he actually modeled this mathematically, and he found that in humans specifically, on average, this is a very rough figure, of course, but on average, every generation of children has about 100 more mutations than their parents did. We're not getting better, we're getting worse. We're not evolving upward, we're devolving downward. Now, how long will it take until we reach a genetic catastrophe where people have real health problems and aren't as viable anymore? That's a question that's kind of hard to answer. But the point is, the Darwinians expect us to be getting better and better, but we're not. We're getting worse and worse. And it's not just us, it's any population of creatures. Time is not the hero of the plot. Time is the villain of the plot. We're getting worse over time. The longer you wait, the worse we're getting. So the Darwinian claim that mutations plus natural selection plus time produces all this wonderful stuff is completely wrong, because that's not how it actually works in the real world. So we've talked about the mechanism for evolution. Let's talk about claims that it's happened in the past. Darwinians like to claim that the fossil record shows all this evidence of evolution, and that's one of the reasons we know that it's true, is that because there's all this evidence in the fossil record. The fossil record supposedly goes from primitive, down here, early in history, to advanced, up here. Well, it's true that there is this rough organization within the geological column, but the stuff that's a result of Noah's flood. But the stuff down here isn't primitive. For example, we found the most complex eye structure known in any creature down here in the Cambrian period in trilobites. They had this amazing compound eye that could compensate for underwater refraction. The engineering in this is really astounding. And these are supposedly among the earliest forms of life. Moreover, the fossil record, in reality, doesn't have this process of evolution anyway. Here's one example. This is an evolutionary tree of insects taken from the Encyclopedia Britannica. And for you younger people, that's this book that us older folks used to have with information in it. So you see how there was this ancestor that had offspring that split into all these trees and so on, and here's today, and here's the early past. Notice, though, that some of these lines are dark, and some of them are dotted. Well, the dark ones are the ones we found fossils for. The dotted ones are the hypothetical creatures we haven't found fossils for yet. So let's remove all the speculation and hand-waving and look only at the actual fossils, the actual data. How much evolution's left? None. Is this a tree? No. It's more of a bush structure, isn't it, where creatures just pop into existence in the fossil record. Some of them have lived on until today, some of them have died out, but this is not a record of evolution, is it? And this is not just insects, it's throughout the animal kingdom and the plant kingdom too. There's missing transitional forms everywhere. In fact, this problem is so bad that there was a school of thought that arose within secular paleontology called punctuated equilibrium to try to explain away the fact that all these fossils were missing. Stephen Jay Gould, who was certainly not a creationist, he was a Marxist and an atheist, wrote about this, and he said the extreme rarity of transitional forms in the fossil record persists as the trade secret of paleontology. To preserve our favorite account of evolution by natural selection, we view our data as so bad that we never see the very process we profess to study. So even in the fossil record, there's no tree of life reflected there. It's more of a bush structure. Like I said, we don't see one ancestor splitting into all these other subsequent generations. We see all these creatures popping into existence, or I should say popping into the fossil record, all at the same time. Now, there's been some minor variations since then, which, like I said, isn't a problem for us, but what we don't see is this overall thing. In fact, notice how most of these all pop into existence all at the same time in the fossil record. This is called the Cambrian explosion. Within just a few million years, all the major types of creatures are just boom, out of nowhere, all showing up in the fossil record at the same time. This makes no sense at all from an evolutionary perspective. And actually, as time has gone on, this problem is getting worse because they're shrinking down the amount of time this had to happen within. But that's a different subject. But all this is quite consistent with the Bible. What we'd expect to see from the Bible is that all these things were created according to their kinds. So we're not surprised to see that when fossils start showing up in geology, that we see the major kinds represented there. No evolutionary trees. So Darwinian claims about the fossil record are incorrect. Other claims, and I'm going to start to move a little more quickly here. Sometimes you'll hear evolutionists say, well, homology proves molecules to man evolution occurred. What's homology? Well, homo means the same, and ology means the study of, so homology is the study of things that are the same. And the argument is that there's this basic bone structure here called pentadactyl structure. Now, if you all hold up your hand. Now, imagine, look at your limb here. You have one bone here, right? You have two bones here. You have multiple bones here, and then you have 5 digits. Okay, put your hands down, thanks. Think about this. You have the same structure in your leg, don't you? Single thigh bone on the bones here, and then your foot's a little bit different structure than this, but it's still the bones in here with the 5 digits, right? We're not the only ones who have this structure. All these other creatures have similar things. Monkeys, of course, make sense, but pigs have a similar structure. Even horses, now some of the digits are a bit different, but the same overall plan. Moles, anteaters, even some sea creatures like dolphins, flying creatures like bats, and so on. Now, the evolutionist looks at this and says, well, this is obvious evidence that we all share a common ancestor. This structure came into existence, and because it works well, it's been preserved through generation after generation, and so that's why so many creatures today have this same structure. Is that good proof for evolution, though? The fact that we all have the same structure or a similar structure? Well, if I'm going to use that logic, let's take it to its logical conclusion. There's a lot of different cars and four-wheeled vehicles in the world today, isn't there? There's convertible sports cars, there's sedans, there's pickup trucks, there's SUVs, all the rest of it. Does the fact that this structure is found across so many vehicles all around the world prove that they all evolved from a common ancestor millions of years ago? Or does it prove that this is a very effective design, and so when these have been designed, the designers, of course, are going to use the best design they have access to, right? This is a very effective design, isn't it, for manipulating the world around us. So it's no surprise then that an intelligent designer would use a good design over and over again. We even do the same thing in our technology today in software. If you use a computer, you've no doubt seen a dialog box like this multiple times to go open a file. You ever wonder why so many different programs all have the same structure for this? Well, because there's a library on your computer that all the programs are accessing to show you the same thing over and over again. Well, the Lord made this biology the same way. Took an effective design and keeps reusing it. Why would he use a less efficient design when creating various kinds of creatures? That wouldn't make sense. So no, homology does not prove molecules to mean evolution occurred. What about vestigial organs? This is a common claim too. For example, whales, here's a skeleton of a whale, they have this little bone back here. Now the evolutionist says, well look, whales have leftover leg bones from back when they were walking around on land. That proves whales came from land creatures. Well, actually, no, it doesn't. This little bone here, it's in the same rough place that a leg bone would be, but this actually has a function during reproduction. It's not leftover useless thing from evolution, it actually has a function. So that's not evidence for evolution whatsoever. The human body, according to this author, has no less than 180 vestigial structures. 180 things in your body that don't do anything. Therefore, they're just left over from evolution. Is that a good argument? Can you imagine if you had all those removed? Well, that would be very bad, because it turns out all of these 180 are now known to have functions. Even the appendix has a function now. Well, let me correct myself. It's always had a function. We just finally know what it does. So to say that we don't know what this does, therefore it doesn't do anything, first of all, that's an argument from ignorance. It just means you haven't figured it out yet. Second of all, it does not prove anything about being left over from evolution, does it? But yet you still see this kind of argument being used. Here's an article from National Geographic. How this cave-dwelling fish lost its eyes to evolution. So the argument is this fish used to have eyes. Today they don't because the eyes have gone away. But that doesn't hurt the creature's survivability because it lives in a cave where there's no light, so it doesn't need its eyes anymore anyway. Now, is this a good example of Darwinian evolution? The fact that this fish lost its eyes? Now, I should say, first of all, I don't know that we actually saw this happen. I don't know that we've been watching this fish long enough. But let's say it did actually used to have eyes a number of generations ago, and now it does not. Does that support Darwinian evolution? Is this an example of going upward and upward? No, it's going downward. It lost something. Isn't this common sense? This is the opposite of what the Darwinians need to prove their model. Yet, what's National Geographic claiming it is? Evidence for evolution. So this is what the public is taught. That something demonstrating the opposite process from what they need somehow supports their model? Don't think so. So much for claims that it's happened in the past. What about claims that it's happening today? Well, if you look in textbooks, you'll commonly see things like this, the peppered moths. Anybody heard this example before? A few hands. So those of you who haven't, this is a species of moth that lives in England. Now, as you can tell, they're speckled. Some of them are mostly white and some of them are mostly dark. Well, on a birch tree, the white ones blend in very well, whereas the dark ones tend to stand out against that white bark. So birds used to preferentially eat the dark ones because they were easier to find. But during the Industrial Revolution, a lot of pollution built up, and the birch trees started to get darker, and so now the dark ones tended to blend in better, and the light ones started to stick out, so the birds started eating the light ones. Then, post-Industrial Revolution, pollution got cleaned up, it went back to light-colored birch trees, and now the white ones are doing better than the dark ones. So we've seen this change in the population over time, from light to dark, back to light again in this peppered moth population. And indeed, as this quote says, industrial melanism, the darkness of the moths, in the pepper moth is still one of the clearest and most easily understood examples of Darwinian evolution in action. So this is one of their best examples of Darwinian evolution happening. But is it actually an example of Darwinian evolution? What did we have before this whole thing started? We had white moths and dark moths. What do we have today? We have white moths and dark moths. Anybody see any big changes there? No. All you've had is a shift in the percentages of these things within the population. Easily explained by natural selection, but not this upwards and upwards progressive change that Darwinians need for their model. And in the interest of time, I'm going to skip together a little bit. Antibiotic resistance. You commonly see this in the news a lot. You hear that, oh, these populations have evolved resistance to antibiotics, so we need new ones. Now, this is a serious problem. I'm not trying to say it doesn't happen. But what I am talking about is this evidence for Darwinian evolution or not? Well, if you look at how this usually works, if you have a population of bacteria, typically the population will have a variety of characteristics and a variety of mutations within it. Now they come out with a new antibiotic, introduce it to the population, and it kills almost all of them. A few that are left happen to be resistant to that antibiotic. And so now, the few that are left, let's say all these ones died, the few that are left, they have no competition anymore for food and such, right? So they start breeding like crazy. So suddenly you have a new population of bacteria with this resistant characteristic built into it. But is this an example of Darwinian evolution in action? Well, no. Most of the time, all the examples that I'm aware of certainly, that characteristic to be resistant was already within that population to begin with. So not an example of onward and upward, it's just an example of natural selection removing things in specific conditions. Moreover, the ones that are resistant usually are resistant because of a bad mutation. The reason they were only a small portion of the population to begin with is because they're usually crippled by something. For example, perhaps they have lost the ability to metabolize a particular nutrient. So when competing with all the normal bacteria, they're at a disadvantage, so there's only a few of them. But when you wipe out all the rest, now the resistant ones can flourish. Is that upward evolution, though? No. The reason they're flourishing is because in this artificial environment, that crippling handicap they had happens to help them. But it's not because they gained an ability, it's because they lost an ability previously. Does that make sense to everybody? Moving onwards. Darwinians, overall, I think I've made the point here, they look at examples of small change in the world today, and they extrapolate that to large change. Hopefully we've seen by this point that it's an invalid way of thinking. As an example of how prevalent this is in our culture, here's a recent example from the New York Magazine, where mice have evolved the ability to live on cheese fries in New York. And this is presented as confirmation of Darwinism in action. Basically, the mice that, living in this part of New York aren't getting as ill when eating leftover pizza and cheese fries that they're finding from people. So this is presented to us as evidence for Darwinian evolution. Well, whether or not a mouse can digest a cheese fry does not tell us we came from molecules. Skipping ahead a bit. Who's heard that our DNA is 98% the same as chimps? Common thing, right? There's a math problem here, though. The chimp genome is 12% longer than the human genome. If something is 12% longer, can it be 98% the same? No, right? Where did they get this number from? Well, they stacked the deck. They looked at only a specific part of the DNA molecule, not the overall genome, to get their figure. So this really is a falsehood that's being promoted to the public. Junk DNA. Who's heard that junk DNA proves evolution? There's all this part of our DNA, doesn't do anything, left over from evolution, not the result of intelligent design. Well, this has been debunked a number of years ago. Most of our DNA does not code for proteins. That's true, but that doesn't mean it doesn't do anything. We're now discovering all sorts of uses for all this DNA, and so it's not junk after all. And my final claim that I'll talk about from evolutionists is that their model isn't mathematically ridiculous. Actually, in the interest of time, because I'm running a little behind, I'm going to skip this one. 10 minutes? Okay, we'll take 10 minutes. There was a man named Haldane a number of years ago who's a geneticist who decided to mathematically model the process of mutations spreading through a population. He discovered that this actually does not work the way his Darwinian colleagues want it to work. He was an evolutionist too, by the way. I'm not saying he wasn't. And this has become known as Haldane's dilemma. So it's called the cost of substitution. So here's an example. Let's say that tomorrow, here in Saskatoon, 2 children are born, 1 boy and 1 girl. And they each have a new mutation that makes them genetically super people. They're going to be just amazing when they get older, physically and mentally. Now, how long will it take for their mutations to spread and become 100% of the entire human population? Long time, right? I mean, if they were fruitful and multiplied and they married and had 10 children, say, then a generation from now, there's 10 of them in the world versus however many billions of people who don't have it. So that spread is very slow, right? What's the one way you can really speed things up? What's the one way you can get it so that 100% of the population has that mutation in one generation? You need to kill everybody else who doesn't have it. That'll get you there, right? And remember, this is how evolutionists think. You win when your genetics becomes the majority in the population. Okay, so let's model then the evolution of people from our supposed ape-like ancestors. We'll start with 100,000 of these ape-like creatures that we supposedly came from. We'll be really generous to evolution. We'll say that each generation of 20 years had a beneficial mutation in it. Now, this is not what we see in nature, but let's, again, be really generous and make evolution as easy as possible. So every generation, there's a new great mutation going to come in that's leading up to us. Then let's kill all the others in the population for that generation to make sure that 100% of the population has this new mutation. And we'll do this every single generation. That means that we're going to, and then we're going to expect the leftover 2 apes to work really hard and replenish the entire population of 100,000 within 1 generation. Now, this is obviously very silly, but we're being overly generous to evolution. We'll give them 10 million years to do this, which is supposedly the time it took for us to get from ape-like creatures to us. In that time, you can produce 500,000 beneficial mutations. Okay? Problem. How much of the human genome does that account for? 0.02%. We supposedly came from ape-like creatures in 10 million years. But even with this ridiculous scenario that I just told you about here, you get that amount of our genome from this process. Anybody see the problem? You can't get to where we are from this ape-like creature in this amount of time. And as I said, this example here is totally ridiculous. Haldane used more realistic numbers, and he figured out that the most mutations that could have accumulated since our ape-like ancestors would be 1,167 mutations, which is 0.000047% of the mutations you need to produce somehow to make us from the ape-like creatures. So mathematically, the evolutionary model is ridiculous. The idea that any of this could happen. Now let's talk about evidence for design within biology. This is a video called The Inner Life of the Cell. It comes from Harvard University, not a bastion of creationism by any stretch of imagination. This shows a white blood cell rolling along inside of a blood vessel. Now this is happening in your body right as we speak. The white blood cell is seeking out inflammation or infection to go fight, because that's its job. And this video is showing some of the biochemical processes necessary for the white blood cell to realize that there's an infection it needs to go deal with and then go off and do it. And the full version of this video is 8 minutes long to explain exactly what we're seeing here. Obviously, we don't have that time, and you wouldn't want all that detail anyway. But we're moving down inside the white blood cell and see what's going on here. Everything you see here is real, by the way. The animators just added a little bit of space in between stuff to make it easier to see. But our cells actually assemble structures for themselves out of proteins. It does this dynamically as needed. When they're no longer needed, then it actually breaks the structures down and reuses the pieces elsewhere. And we recycle them frequently. As structures are needed, they're made. As they're not needed, they're disassembled. This is called a motor protein. This is real. This is what it actually looks like. You've got a bunch of these little guys in all of your cells. It's moving a vesicle of proteins up to the outer surface of the cell.
Looking down inwards, we're moving toward the nucleus. DNA is inside the nucleus, being read to get instructions and then transcribed onto RNA. These are strands of RNA containing instructions to build proteins. And then those instructions are read, and the instructions are then used to build proteins. Various pieces are made and assembled. Now, a protein is a molecular machine. Your cells have hundreds of them, each designed to do a very specific task, each assembled to do a very specific task. On this example here, a lot of them are being assembled into these sac-like structures called vesicles to move up to the outer surface by our little friend, the motor protein here. Once they reach the outer surface, and obviously I'm skipping a lot of detail here. Once they reach the outer surface of the cell, their contents are released. All the various pieces are used to assemble various things. We're about to see a cholesterol raft being built as its foundation for this. Now these are hooks that are about to unfurl once they're all ready. They're going to grab between the white blood cell and the blood vessel that's rolling along to tell the white blood cell to stop, put the brakes on, and immediately disassemble all those structures it had inside of itself so that it can flow in between other cells and go seek out the inflammation that it just realized was there to fight. Now again, that's a tremendous amount of detail.
But my point is, there's amazing stuff going on in every single cell of our bodies right now. And to think that this all just assembled itself from random processes is a non-starter. And we could have a whole session just on evidence for design within biology, by the way. Last item I will talk about. How do we know who the designer is? How do we know that the Bible accurately identifies the designer? Well, as I said, the Bible is its own authority. And we accept it as true, so we don't need to prove it. But the Lord has, in his grace, given us a lot of evidence to support that as well. Here's one specific one that I really think is wonderful. In our cells, we have DNA. Now, the DNA is found in chromosomes. The DNA is wrapped up in these strands of chromosomes. Where do you get the DNA in the nucleus of your cells from? Where did the DNA come from? Mom and dad, right? That's your parents. Their genetic material defines who you are, or at least physically. However, there's another place where you have DNA, and that's in the mitochondria of your cell. So this is the cell. The cell has all these little structures called organelles. Some of them are mitochondria. These are like little power plants. Mitochondria have some DNA too, but you don't get this from your parents. You only get it from your mother. Your father didn't contribute to this. So you have mitochondrial DNA that came exclusively from your mother. Where'd she get hers from? From her mother. Who got it from her mother and all the way back, right? People are taking genetic samples from folks all over the world and comparing their mitochondrial DNA. Turns out most of our mitochondrial DNA from people all over the world is very similar, but there are a few differences here and there. And they're able to figure out that these differences have come from specific mutations introduced to the population at specific points in time. Because if everybody in the world has the same part of their DNA, except for this one group over here with one little difference, then you can realize, okay, well, a few generations ago, some woman in this area had a mutation, and then everybody descended from her today has that. But we know what the original one had, because everybody else has that same thing. Now, they are reconstructing DNA for female ancestors for people all over the world using this technique. And evolution says we all came out of Africa as a population of hundreds of thousands of creatures. So how many ultimate female ancestors should everybody in the world have, according to evolutionary theory? Hundreds, thousands maybe, right? How many ultimate female ancestors do we all have according to the Bible? One. How many ultimate female ancestors does everybody on this planet have according to our mitochondrial DNA? One. The evolutionists have named her Mitochondrial Eve. Now, they think they're being tongue-in-cheek and funny about it. But think about this. Genetics confirms everybody on this planet came from a single woman. How long ago did she live? Well, how would you figure that out? Well, you'd figure that out by saying everybody on the planet today has an average number of mutations. Not that many, by the way. It's about 40. How long would it take to accumulate 40 mutations in mitochondrial DNA starting from the single woman? The answer is about 6,000 to 10,000 years. So think about this. Everybody on this planet today came from a single woman who lived 6,000 to 10,000 years ago. The story gets better. There's also a similar thing going on with Y chromosomes. Y chromosomes are found in men. Guys, where do we get our Y chromosome from? From dad. Mom didn't contribute because she doesn't have one. Where'd our dad get his from? From his dad, all the way back. Same thing applies. They're taking samples and mapping out mutations. How many ultimate male ancestors does the human population have today? 1. How long ago did he live? 6,000 to 10,000 years. The evolutionists have called him Y chromosome Adam. Now, if you look, you can actually look this up on Wikipedia. Mitochondrial Eve has her own Wikipedia page. They will tell you mitochondrial Eve lived like 150,000 years ago. Why is that? Because they've tinkered with the numbers that produces the mutations. You read the papers where they're working this out, and they say, well, the summary of the paper says mitochondrial Eve 150,000 years ago. The data say 6,000 to 10,000. But then they say, well, here's what the data say, but we know this must be anomalous because we know we came from Africa hundreds of thousands of years ago. Therefore, the real rate must be such and that's what they put in the summary of the paper. But the actual data, mitochondrial Eve, Y chromosome Adam, we all came from them thousands of years ago. That's in the DNA in every cell in your body. In Matthew 10, the Lord said, the very hairs of your head are all numbered. Now that's true, but I also like to think of it this way. Every hair in your head is made of cells. Those cells contain DNA. Every hair in your head confirms you are a child of Adam and Eve. And I think that's awesome. Because indeed, biology proclaims the glory of God, as do the heavens and everything else that he made. As the psalmist wrote, how precious also are thy thoughts unto me, O God. How great is the sum of them. I will praise thee, for I am fearfully and wonderfully made. Marvelous are thy works, and that my soul knoweth right well. The more we learn about biology, the less excuse we have for denying a creator. Not that we ever had an excuse anyway, but the Lord has, in his grace, made all these things accessible to us today. Thank you for your attention, and I'll see you again this afternoon. Thanks.